Hello and hi with content of 4 members, which is include Tan Zifeng, Teo Huyin, Liu Yuhao, and myself, Muhammad Faris Iqmal bin Muhammad Aris, matrix ID MA2122. We are gonna presenting to you about the stroke cycle engine of the internal combustion engine. To begin my presentation part, I would like to introduce you with our content, which is include the introduction that we will discussing about the introduction, objective and problem statement of this project, and the second one is the best design chosen based on the problem statement, and the third one chosen design work to achieve the objective, and the next one is the drawing, which is include the movement of the structure in GIM software, and another one is calculation, and for the last one, which is the result and discussion, that will include the calculation using GIM, graph of kinematic from GIM, and a discussion about the software and the calculation. For the introduction, we need to know what is the four-stroke cycle, which is a four-stroke cycle is an internal combustion engine in which the piston complete 4 separate stroke include the intake, compression, power, and exhaust stroke while turning the crankshaft to complete one operating a cycle. The stroke refer to a full travel of the piston along the cylinder in either direction. So during the intake stroke, the piston will travel downward. At the same time, the intake valve is open and the exhaust valve is closed. And during the compression stroke, the intake valve and exhaust valve will close and the piston will move upward. The upward motion of the piston has caused the air or fuel mixture to be compressed in the combustion chamber. For the power stroke, the spark plug fire and ignite the compressed air or fuel mixture at the end of the compression stroke. So the explosion has forced the piston to move downward and rotate the crankshaft, thus propelling the vehicle forward. Okay. At the same time, the intake and the exhaust valve are closed. And the last one is the exhaust stroke, which is the intake valve will be closed and the exhaust valve will be open, thus allowing the piston to push the spent exhaust gas out of the engine when it rises. And then the fourth stroke, which is one cycle, is completed and the process will be repeated again. For this project, its content are 4 objectives, which is to apply the theory and formula learned in the class, and the other ones are the art to determine the angular velocity of the crankshaft in the stroke cycle engine, which is will be concluded in the calculation section. And the third one is to apply simulation motion of the stroke cycle engine in GIM software, which is will be discussing at the result and discussion. And the last one is to study the geometrical mechanism of dynamic system. Have you ever thought about how the internal combustion engine works? An internal combustion engine is the main source of power which is used fuel to burn and cause the vehicle to move forward. It using a 4-stroke cycle to operate, which are intake, compression, combustion, and exhaust to cause the explosion. When the explosion occurs, it will cause the piston to move downward during the power stroke and then turn the crankshaft. Okay, for our case study, which is the piston P move forward, move upward with velocity 7.5 at the instant shown. So we have to determine the angular velocity of the crankshaft AB at the instant.
Good day, I'm Liu Yuhao, and today I would like to present about the model drawing in GIM software. So first of all, the information is taken out from the question, which is the length of rod AB, length of rod BP, and the velocity of the piston P. So in Gym software, the first point plotted is the origin point. Second point plotted is for the point B, which is 36.25 millimeter. Then third and fourth point for the fixed rod is plotted. This 2 point plotted is to make a slider, and it should be fixed. Then rod AB is formed with a fixed joint, and lastly a slider point with the distance 38.75 respect from the point 1 is plotted. Then the joint is, and lastly free joint is plotted, slider is plotted, and lastly the slider point P is plotted. And this is our simulate model in model questionnaire, and its motion should be look like this. That's all from me. Thank you.
Hello everyone, I'm Dan Ji Fan. So now we will use our manual calculation to solve our problem. The problem shows that the piston P move out 7.5 meter per second, and we have to determine the angular velocity of the crankshaft AB at this instant moment. First, we will draw out the free body diagram for our problem first, and then we will draw also the geometry for our problem. From the geometry, we can define the angle at the B. Therefore, we can write out the cos theta is equal to 0.03625 sine 30 over 0.125. And then finally, we will get the angle is equal to the 81.66 degree. For the link BP, we have get the velocity of the piston is equal to 7.5 J, and the velocity B is equal to negative VB cos 30 plus VB sin 30 J, and the angular velocity is equal to negative omega BPK. This is due to that the angular BP is run on the clockwise directions. Next, we also will write the RPB is equal to negative 0.125 cos 81.66 I plus 0.125 sin 81.66 J, which is here. So from this free body diagram, we know that the VP is equal to VB plus omega multiplied with the RPB. And then we will find out the equation, which is 7.5 J is equal to negative VB cos 30 plus 0.125 sine 81.6 omega PP I plus VB sine 30 plus 0.125 cos 81.66 omega BPJ. And then we can equating the I and J component use. Therefore, we will get two equations. First equation is 0 equal to negative VB cos 30 plus 0.125 sine 81.66 omega BP. Then second equation is 7.5 equal to VP sine 30 plus 0.125 cos 81.66 omega BP. Therefore, we can solve these two equations by calculator, and we will get the angular velocity for BP is equal to 83.77 meters per second. And the velocity at B is 11.96 meters per second. After we get these informations, we can know that the crankshaft AB rotates about the fixed point A. Hence, the velocity B is equal to angular velocity AB multiplied with the RAB. Finally, we will get the angular velocity AB is equal to 330 radians per second. Now, I will pass to my team members still to continue the presentations.
Hello everyone, my name is Tiêu Huyin. So right now I'm going to continue on the calculation using the GYM software. By using the GYM software, we set that as the slider move at the 7,500 mm per second, move out at that instantaneous, and the angular velocity of the rod BP, which is the 83.707 radians per second. And for the rod AB is 329.838 radians per second. Next is the graph of kinematics, velocity, and acceleration from the GYM software. As you can see, the right side is the position against the time graph. So this graph shows that as the time passes, the position of the slider is kept increasing. In 1 second, the slider has moved up to 7,500 mm. Next is the velocity against time graph. The velocity of the slider is kept constant throughout the time, which is 7.5 meters per second, or in this graph is 7,500 mm per second. Next is the acceleration against the time graph. Since the velocity of the slider was kept constant, which is 7,500 mm per second, so the acceleration of the slider is 0 mm per second squared. Now I'm going to continue on the discussion about the GYM software and manual calculation. So we done the stimulation using the GYM software, and we have got the value for the velocity of the P, which is 7.5 meters per second, while the angular velocity of the BP is 83.70709 radians per second, while the angular velocity of the AB is 329.838 radians per second. While using the manual calculation, we have got the value for the velocity of P is 7.5 meters per second, while the angular velocity of the BP is 83.77 radians per second, while the angular velocity of the AB is 330 radians per second. So from the table below, we can know that the value between the stimulation and the calculation was not much different. This is due to the decimal place of the element has been used was slightly different between the stimulation and the calculation. And this difference does not affect the internal combustion mechanism. And last, we can conclude that we can use the GYM software to stimulate or can calculate the mechanism, as it is not much different from the actual calculation. So last, thank you for listening to our group presentation.